The ocean covers most of our planet, a vast blue expanse full of mystery and wonder. It supports incredible life. Humans depend on the sea for food, transport, and energy. We build mighty structures in its embrace. But this marine world fights back, quietly, persistently. This silent siege is called corrosion. It's a natural process. It targets our strongest materials, especially metals and salt water. If we ignore it, the consequences are dire. Safety is compromised. Economies suffer enormous losses. Let's begin this exploration together. What exactly is corrosion? It's a natural process that gradually destroys materials, especially metals, through chemical reactions with their environment. Think of it as nature reclaiming its elements. Over time, metals deteriorate, weakening the structures they form. Metals, like iron and steel, are refined from ores. This process transforms raw materials into useful forms. This refining process requires energy. The metals are then in a higher energy state, making them more reactive. The metal is in a higher energy state. This makes it prone to reacting with elements like oxygen and water. Nature prefers lower energy states. It seeks balance by breaking down these high-energy metals. So, metals try to return to their original form. This is why we see rust forming on iron and steel, like rust, similar to iron ore. Corrosion is this reversion, a slow, steady transformation that can be quite destructive. This natural process has profound effects. It can compromise the integrity of structures, leading to potential failures, especially on structures built in or near the sea. The salty, humid environment accelerates corrosion. Marine structures are our lifelines. They are crucial for transportation, energy, and trade. Ships, bridges, offshore platforms, and pipelines all face the constant threat of corrosion. Regular maintenance is essential. Understanding corrosion helps us reduce this burden. By studying it, we can develop better materials and protective measures to extend the life of these vital structures. Corrosion, especially in seawater, is an electrochemical process. What does electrochemical mean? Electro refers to electricity, the flow of tiny particles called electrons. Chemical refers to chemical reactions, atoms changing partners, forming new substances. So, corrosion involves both electricity and chemistry. It's like a tiny unwanted battery working tirelessly to consume metal. A microscopic battlefield. This battery needs specific components. 4 key players are involved: the anode, the cathode, an electrolyte, and a metallic path. Seawater acts as the electrolyte. Electrons flow through the metal. Ions flow through the water. This completes the corrosion circuit. When metal weeps real-world corrosion catastrophes at sea, history is filled with examples of maritime disasters caused by corrosion. These tragic reminders highlight the destructive power of corrosion. Consider the wreck of the RMS Titanic, one of the most famous maritime disasters. While an iceberg caused her to sink, corrosion is what consumes her now, slowly but surely. Lying deep in the Atlantic, the Titanic is a haunting example of marine decay. Microbes and salt water work together in a relentless process, forming rusticles, icicle-like rust formations that are slowly eating away at the steel hull. These rusticles are a dramatic example of marine decay, showcasing the relentless power of corrosion. A dramatic example of marine decay can be seen in any working harbor. Look at any working harbor and you will see corrosion in action. Ship hulls are constantly battling rust, a never-ending fight against the elements. The iconic red-brown color of rust is iron oxide, a sign of ongoing corrosion. If left unchecked, this rust can weaken the hull, leading to leaks or even structural failure. Regular maintenance and painting are essential to prevent such damage. Without these measures, ships can suffer from leaks or structural failure. Regular maintenance and painting are essential. Port structures also suffer from corrosion. Piers, jetties, and seawalls, often made with steel-reinforced concrete, are also vulnerable to the relentless march of corrosion. Guarding our giants, strategies to combat marine corrosion. Marine vessels, from the smallest boats to the largest ships, face a relentless enemy: corrosion. This natural process can weaken structures, leading to costly repairs and even dangerous failures if not properly managed. We're not helpless against corrosion. Through a combination of science, engineering, and practical know-how, we can significantly reduce its impact. Science provides us with powerful tools. Researchers and engineers work tirelessly to develop and refine methods to combat this persistent problem. Several strategies can prevent or slow it down. These strategies range from selecting the right materials to applying advanced protective coatings. The first line of defense is material selection. Choosing metals that are inherently resistant to corrosion can make a significant difference. Some metals are naturally more resistant. For instance, stainless steel is a popular choice due to its durability and resistance to rust. Stainless steel, for example, contains chromium. This element is key to its corrosion resistance. Chromium forms a protective oxide layer. This layer acts as a shield, preventing further corrosion. Titanium is also highly corrosion resistant. Its strength and lightweight make it ideal for many marine applications, but these materials can be expensive. The cost of using high-end metals can be prohibitive for some projects. Protective coatings are widely used. These coatings provide an additional layer of defense against the harsh marine environment. Think of paint on a ship's hull. This paint isn't just for aesthetics. It plays a crucial role in protecting the metal beneath. This isn't just for looks. The paint creates a physical barrier that helps to prevent corrosion. The paint creates a physical barrier. It separates the metal from the seawater, which is a primary cause of corrosion. It separates the metal from the seawater. This simple yet effective method can greatly extend the life of marine structures. Advanced coatings, like epoxies and polyurethanes, offer superior protection. These materials are designed to withstand the harshest conditions. Cathodic protection is a clever electrochemical trick. It involves making the entire structure act as a cathode in an electrochemical cell. It turns the entire structure into a cathode. This method can be highly effective in preventing corrosion, using sacrificial anodes or impressed currents. These techniques ensure that the metal structure remains protected, even in the most challenging environments. The constant battle vigilance against the corrosive tide. Marine corrosion is a relentless adversary, a fundamental force of nature. Driven by the laws of electrochemistry, it constantly seeks to return metals to their more stable, oxidized states. This process affects all marine structures, from the smallest boat to the largest supertanker, from coastal piers to deep-sea pipelines. The salty ocean provides the perfect battleground for this slow, persistent decay. But human ingenuity fights back. We've developed effective countermeasures. Careful material selection provides a strong start. Protective coatings form essential barriers. The battle against marine corrosion is ongoing.